Welcome Algebra 2, and we are going to be going through the Unit 2 applications. How do you apply inequalities to real world problems? Today, it's going to be a tiny bit of a challenge. I'm going to challenge you guys, so mentally prepare. And at the end of this, yes, it'll be something new, but I promise you'll get through it as long as you just try, and as long as you do your best, and as long as you learn from your mistakes, okay? Some phrases that are going to be very helpful for you just as you analyze word problems are phrases such as x is at least a. Okay, well that just means is x is greater than or equal to a, which is just some old number. Okay, x is no less than a. That means it better at least be the number we're considering and greater than or equal to. So if x is no less than 5, then we have x is greater than or equal to 5. Okay, so definitely be writing down these particular tidbits of knowledge. Similar idea with less thans. X is at most b, x is no greater than b. Certain problems, x is between a and b. And there's also an inclusive and exclusive. I will be specific. I'll help you decide whether it's less than or equal to for both of these. So I will state if it's including or excluding, okay? All right, so let's jump into example number 1. Find the smallest set of 3 consecutive odd numbers whose sum is greater than 720. Word problems, it's all about translating this into algebra. Okay, so let's start with what we know. We know that the word sum means to add. Hopefully you know the word sum means to add. If not, if you forgot, that's okay. Greater than 720 means greater than 720. All right, so that's easy peasy stuff. The trickier stuff is this here. 3 consecutive odd numbers. 3 consecutive odd numbers, okay? First off, a consecutive number is a number such that follows the next. So 1, 2, 3 are consecutive odd, or are just consecutive numbers. Consecutive odd numbers would be numbers like 1, 3, and 5. Now, I know you could just start guessing, but I really want you to start to show your work and thinking algebraically. Notice this here. All work must be shown for full credit on word problems, and that works from here on out. You'll likely only receive partial credit, half, if maybe less, if you just guess, okay? The idea of this course is not that you can guess and check, it's that you build your algebraic knowledge and skills. Okay, so I like to draw out what's going on here. 3 consecutive odd numbers. I know I'm going to have 3 numbers, so I draw little spaces, and I'm going to be adding them because of their sum, and that's going to need to be bigger than 720. Okay? And I need an odd number 1, an odd number 2, and an odd number 3. Here is the trick to these problems. Once you get the trick down, it'll take a few attempts, or you'll get it though. It's really not bad. An odd number is in the form 2k plus 1. K is an integer placeholder. What I mean by that is k is not actually your solution in the end. It's just going to tell you where to start. So if we plug in any number for k, we're going to get an odd number here. So let's just think. If we try 2 times negative 8 plus 1, that's going to be negative 16 plus 1 is negative 15. Hey, that's an odd number. 2 times 31 plus 1. That's going to be 62 plus 1, 63, and so forth. Even 2 times 0 plus 1 gives us 1. So k is our general number, our placeholder. We plug it into the odd formula. The odd formula. That's a neat name for it. And then that generates our number. Likewise, we'll see in number 2 here, we're going to be dealing with even numbers. Evens, so I would write those things down, isn't just in the form of 2k. And that is because even numbers, all of them are divisible by 2. And odd numbers, they're divisible by 2, but then you add 1 to make it odd. Okay, with that tidbit of knowledge, we can fill in our gaps here. We know that the first odd number is going to be in the form 2k plus 1. Okay? The next odd number, it's going to be very similar, but let's just think, okay? Think over here. If the first number was, I don't know, 13, the next number would have to be 15 in order to be its next consecutive odd number. What you're doing from 13 to 15 is you're adding 2. So mentally, I'm adding 2 to 2k plus 1. That would make it 2k plus 3, essentially. And then the last number would be 2k plus 5. Okay? Now, I promise, okay, this really, it's easy once you get that down. That, I know that was scary. But from here on out, it's easy peasy. What we'll do is just add like terms. 2k's, that's 6k plus 9 and greater than 720. All right. Solve for k. So 711 and 6k. And our placeholder, remember, it's a placeholder. It is not the actual answer. Needs to be greater than 711 divided by 6, 118.5. Okay, with that being said, k needs to be an integer, so we're just going to round up to 119. So this 119 is the k to start at to find our true answers. So again, don't just stop here. Don't stop. Keep going. That's not the answer. The answer, remember, odd number 1. Number 1 is 2k plus 1. So we want it to be 2 times 119 plus 1, which 2 times 119 plus 1, I did it up ahead there, 239. All right, well, next in line, if we did this correctly, odd number 2 is going to be 2 times 119 plus 3. Well, that should be, of course, 241. Still odd, so we're okay. And odd number 3 is 2 times 119 plus 5, which is 243. Okay? It's a good idea to check to see. Like, all that work, I don't know what we're doing here, but let's just see if it works. That all added together should be greater than 720. So 239 plus 241 plus 243 greater than, it's 723. Now, just to show you, let's say we picked, I don't know, if we got a different k value, let's say we picked 118. 118, so 2 times 118 plus 1, that would have been 237. So 237 plus 239 plus 241. That would have been slightly less than 720. So that placeholder needs to start at 119. Now you could have found k in at least 119 You could have also used 120. You could have used 121. You could have used 507. But the fact that I want it to be the smallest set just means to start at that number right there. I might ask you to find at least 2 sets. That just means you pick another value. Great job. I know it's a lot, okay? But just bear with it. Try. And again, set it up. Use some algebraic skills. And we're going to be doing practice. So let's just get into the next one, okay? Practice makes perfect. Okay. Find the smallest set again. 3 consecutive even whole numbers whose sum is greater than twice the middle integer. That should say whole number. Twice the middle whole number. Okay? So don't really let the whole number stuff confuse you too much. Let's again just start from the top. So 3 consecutive even whole numbers means I'm going to have even 1 plus even 2 plus even 3. And what does it say? Sum is greater than twice the middle whole number. So their sum is greater than even 2 and 2 times that. Okay? Now, just like before, we talked about odds. Even numbers are in the form 2k. So our first even number, we'll just let that be 2k. So, and again, for example, let's say it is 54. Well, the next one in line that's even would be 56. So you're adding 2 again. So this next one is 2k plus 2. And then 2k plus 4, because we're adding 2 to each of these. For the last part here, we have 2 times, so lots of 2's. So I'll use a color. This 2 is just the product 2, the multiply by 2. And twice the even number. Our even number is in this form, 2k plus 2. So we'll just put that there. The setup, maybe a little shaky. The solving, easy. Okay, so we're just going to add our like terms. 2k, 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 6k. Plus 6 is greater than distributing 4k plus 4. A little inequality to solve. That really should not be too crazy for you. I hope. And then divide by 6. And we get k needs to be greater than negative 1/3. Our k's, they're always integers. So we are just going to round that negative 1/3. We're going to round up. And the next one would actually just be 0. And all that just to find k is equal to 0. Let's see if it works out here. Even number 1 is just 2k. So 2 times 0. Even 2 is going to be 2k plus 2. And even 3 is 2k plus 4. So we have the numbers 0, we have numbers 2, we have numbers 4, 0, 2, 4. Let's see. Is that sum 0 plus 2 plus 4. I know that's 6. Is 6 greater than 2 times the middle number? Well, 2 times the middle number is 4. 6 is greater than 4. Okay, so all that for a little k of 0. If you get negatives and stuff, typically you're just rounding. Same with decimals. So you didn't do anything wrong. You just want to round it. And again, k is a placeholder. So that's not your actual answer. These are your answers. 0, 2, and 4. Okay, everyone, our last example here. A poster has a length that is 3 times its width. To fit in a frame, 2 centimeters is cut off each side. The resulting perimeter must be at most 44 centimeters. What are the largest possible dimensions of the original poster? So what we're dealing with is a poster. Okay, I love these problems because I get to draw. I encourage you guys to draw something too. Okay, maybe it's Star Wars and it is, I don't know, Star Wars Episode 10. He's got a lightsaber, and it's like a double-bladed Kylo Ren one. That would be kind of cool. I don't know. Anyway, no. All right, let's get to it. Anyway, the resulting perimeter, 44 centimeters. What I was getting at, the width, okay, is here, and it really doesn't matter, but just remember now that the length is 3 times the width. So that means this must be 3 times W, or 3W. Okay, the next thing, the resulting perimeter. Perimeter, when we're dealing with that, perimeter is equal to 2 times the length plus 2 times the width. Now in our case, it must be at most 44 centimeters. Okay, so I just want to rewrite this as 2 times our length, which I'll plug in here, plus 2 times our width, which I'll plug in here, needs to be then less than or equal to 44. At most, remember, is less than or equal to. All right, centimeters, just so we don't forget. Now, the length and width we are considering are those of the trimmed poster. So originally, or the poster we're dealing with has a width, and we know that 2 centimeters were cut off from each side. So minus 2, which means that our width is W minus 4. Okay, and length and width are interchangeable as far as these go. You could have it in either spot. Okay, on the other side, the length is 3W, and again, we cut off 2, and we had cut off 2, so it's 3W minus 4. All right. Getting that out of the way, I think is really the most challenging part. So from here, we're just solving an inequality. We'll have to distribute 6W minus 8 and plus 2W minus 8 is going to be less than or equal to 44. Combine our like terms. 8W minus 16 less than or equal to 44. We'll add. So hopefully this is all relatively simple stuff here. And then we get a fraction, I believe, or a decimal. 60 divided by 8, 7.5. So W must be less than or equal to 7.5 centimeters. Now the formal answer, okay, I want the dimensions. So the largest possible, what that means is that we need to consider that it's 7.5 by, okay, 7.5 by, this is 3 times 7.5. 3 times 7.5 is 22.5. Okay, centimeters and centimeters. Well, as you answer these questions, if you want to draw out a diagram like this, that is fine. If you want to write out the answer, 7.5 centimeters, and the length is 22.5 centimeters. That's perfectly fine as well. I would accept either answer. Do remember to have units. Don't forget those. It's a little half point that I would take off. And that's really it. So word problems, I know they can be challenging. So please just try them. That's all I'm asking you to do is try. Do your best. And okay, again, make some mistakes. It's okay. And in the end, you'll get it down. So just definitely practice the next problems. I will make a separate video kind of walking you through, or at least setting up, some of the practice problems. So feel free to watch that. Try them out first, then go back and check out the movie or just look at the answers. So great job, guys, and take care of that.